Welcome to the amazing microbit Python spoon race. Shake it. Skeleton. Bad news. But the fun part is, it takes damage slowly. So, the idea is, you'd get a group of friends, perhaps a group of students in a class, each one with one of these, and you try to win a race while having some life left in the end. I'll just show you what it looks like. So here we are. We've already lost a little bit of life. I'm going to try to get to the end of the room reasonably quickly. Actually, I can't go quickly anymore. But yeah, reach the couch. Winner! So, hello and welcome. This is going to be the coding part of the tutorial. So, before we start, I am using microbit Python. So if you just search it in Google as microbit Python, you're going to arrive at the same editor, very first link. You download programs by basically clicking the download and then dragging them in. I'm going to do one very quickly. I'm also using something called Terraterm, which is this thing right here, and it's going to help me display sensor values. You can complete the tutorial without Terraterm, so this is just something that helps along with troubleshooting. So here's my first program, and you download it, and then you want to drag it out. Basically, you want to drag it into the microbit, which appears like a USB on your computer, basically. So that's what it looks like when it uploads. And if this program works, you're going to see the image of the microbit have a smiley face. They're so pretty. And you're also going to see, ooh, you also should see values appear here. Oh, there they are. So if I take the accelerometer, even sort of twist it sideways, you're going to see, and if I shake it, there's going to be much bigger differences. You're going to see that sensor reacting. Now, z-axis is actually axis on the vertical, which means it's sensing gravity. So minus 1,000 really stands there for your 1g acceleration due to gravity. Which is why, if I was to flip it upside down, you're going to see 1,000. So it's the same sort of force, but in opposite direction. So there goes back my little microbit onto its blue tack. So now what we're going to do is start with just adding an if statement. And this if statement is going to have like a skull face if accelerometer values go above a certain amount. So we can just start off with an absolute value and just do something like this. If an absolute value of z is greater, so it doesn't matter if it's plus or minus, is greater than, I don't know, 1,500. So this is about 1,000. If it gets to 1,500, then we can display.show, and instead of image.happy, we can just do something like skull. So download this, save, and we need to drag it onto the microbit. I'll do that off screen. So it's uploading now, and that technically means all we gotta do is shake this guy. And there we have it. That's the skull. So now we want to try adding life. And basically, having this work at any angle. So we're going to have life, and we're going to set life to some arbitrary value of, I don't know, maybe 10,000. Because 1,000 is what's happening at this very moment. Then I'm going to think about taking two subsequent measurements that are apart a certain amount of time, and if we can calculate the difference between them, and then that could be the new value of the shock. So if I simply had like Z1 and Z0, so let's see, sleep 20. So if I had something like this, so these would be two subsequent values. I can call one Z0, the other one Z1, and then I can create something called shock, and shock equals to absolute value of Z1 minus Z0. So the second value minus the first one. That should work. So now I can print shock, and the values are gonna fly by pretty fast. What I'm expecting to see are actually really slow values. So instead of Z, I'm gonna save absolute value of shock, and I don't need to do absolute because it's just shock. So if shock is greater than, and this time around I can just say 200. So let's see if that works. And if it does, what is going to happen is basically we're going to have a bunch of zeros on the screen. This is the upload. Yes, that's beautiful. So it does go up to 16, but like if I whack the table, we got it turned to a skull. So I can reset it from underneath. It's on that side. Whack the table, it's a skull. So this is much better. And technically, if we really tilt it slowly, see, nothing happens. As long as we don't move. We can even get a 0 by holding it. So this does exactly what I want. So I'm pretty happy with that. Now, to make this sensitive in every direction, we can add accelerometer values for all of the other axes, X, Y, and Z, and then have the shock add up for all of them. At which point, we can calculate life. I mean, we can start by calculating life immediately. So let's just say life equals to life minus shock. And now we can say something along the lines if life is less than 0. Then we can display that. And we can print life. So in this little extra version, now we should get like 10,000 printed on the screen, decreasing ever so slightly. But when we shake it a lot, there we go. So that's life. As you can see, it does still go down. So what we can do is we can do a little test here. Like, we'll only reduce life if shock is above a certain threshold, but we shake it and life goes to 0 really quick. We're onto the skull face. So just one little troublesome point. So we can only reduce life if shock is greater than, I don't know. Because 16 seems to be something that can trip in any direction. So 3 times 16 is 45. Let's go 60. And I'm going to be pretty confident that that works. So right now, I'm going to do it on all 3 axes. So here we go. So we got X, Y, Z. This is going to be X0, Y0, Z0, and this is going to be X, Y, Z. And here we're going to have X1, Y1, Z1. We're going to have X, Y, Z. So we got 3 axes, and we're just going to add the absolute values of the other two. So I guess I can go X, X, Y, Y, and Z, Z. So here we go. We've got all of the shocks from all of the dimensions adding up. We have them adding to this variable shock. Shock only, however, subtracting from life if it reaches a certain threshold. So I think this is ready for a test. And if this works, we can go straight onto the part where we try to represent shock with pixels. Wow, as you can see, it's not decreasing. Now, if we can decrease it when we shake it, and we can, we got to the skull face again. So, one more time. We start off as happy face, shake it, skull face. As you can see, maybe we should have had more life. But nonetheless, this works great. So you can always change the values. You can change this threshold right here. This is a value to adjust. And we can also say adjust life here. Okay, so what's left? What's left is to draw this sort of grid of pixels, which is going to be decreasing with decreasing life. So let's start by conceptualizing an idea that there is 25 LED lights. So if we just come up with a number, like, if we say lights, and if we at the very start of the game have 25. Now if we've got 1,000, so we would have to take the calculator and split 1,000 into 25 pieces. So 1,000, or was it, life is 10,000 divided by 25, that's 400. So lights equals to life over 400. Convert it to an integer. Int life divided by 400. So that ought to help. Now, if we were to print lights, I think we should get the right number. And I'm going to download this because it's definitely worth troubleshooting a little bit. So I'm going to drag this on. And what I expect to see is a number that starts off at 25 and then goes down as I shake it. Yep, beautiful. 25, 23, 22. And if we hit this stable, it's going to go all the way down. It's even going to go negative. Okay, so this lights idea definitely works. So now we got to map it out from this variable onto the grid. So let's have a think. First, I want to show you the command that prints the pixels. So it works like this. Display dot set underscore pixel, and then the values are x, y, intensity. Now we're always going to keep the intensity at a 9, which is the maximum, and we got to figure out the x and the y. So in order to set all the pixels, I would do something like this. For x in range 0, 5, and then for y in range 0, 5, and then you could do that. And now all of them would just go on, and just to test that this whole thing works, I'm going to upload this program. Sorry, to drag that out. I'm going to upload it, And if this program works, if it works just fine, all that's going to happen is that we're going to have all of these LEDs just go on. And that's happening. They're all on. So now, at least I want to get life to control how many of them go on. And I think the start is by perhaps just controlling Y. And having this limit, this upper limit on Y, should be a start. So if we say for Y in range, I think if I create something like this, Y eval, and what would that be? Y val equals to lights divided by 5 with no remainder. So that would basically, like 25 divided by 5, that's 5. But if it's 23, it would go down to 4 because it ignores the remainder and there's no decimal. So let's try if that works, right? So this technically should get us like a line at a time. Again, I gotta have that folder open, microbit dragging on. So I'm gonna try not to even breathe because I want to make sure that, oh yeah, so good. Come on. Okay. Ah. Right. So I believe that everything is working except, right, that the screen never really goes off. So once you turn on an LED, it stays turned on. So I would need to have like a clear screen somewhere. It's called display dot clear. And it doesn't really matter where I clear the display. It could be above or below. This delay by which they were on, technically it's right there. So we're gonna draw this, have these two delays happen, and then we're gonna clear the display. So maybe, just maybe, that location of the display dot clear really matters. So let's try that again. Optimism. Ha. Now, moment of truth. Yes. Good. Good. Good, 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 good. So, if life is less than 0, we're going to show the image of the skull. And I would say we should then sleep 5,000 and then break. Okay. This is looking more and more promising. So now that Y works, one other thing that I want to try is X. And X would be defined by simply taking the number of lights, X val, by taking lights and just, dividing them by 5 and taking the remainder. So let's say number was 23. Well, if you go 23 divided by 5 with no remainder, that'll give you 4, height of 4, but then 23 divided by 5, the remainder of that is 3. So that'll give you 3. So 3x and 4y, and that ought to do it. Really, that ought to do it. So I'm going to say for x up until x val. Moment of truth. Here we go. Oh. So now it disappears from that direction. Yeah, it kind of works. And then you get your skull face. Let's have a think. I have a feeling that we actually have to go up until 5 here and then draw those extra x1s separately. And first of all, this is only relevant is if y_val is less than 5. So if y_val is less than 5, what we want to do is just draw, however, 1, 2, 4 x lights. And the way we're going to do that, for x in range, exactly what we had here before. So I'm going to copy this, because I'm going to put it in. It's going to be 0, x val. And then I'm going to put that there. Except instead of having y in the full range, we are just going to say y val. So I think this is going to do it. Let's try it. 17 iterations. I think this whole thing gives you an idea of what programming is really like. A fair bit of trial and error. I had done a program just like this from scratch 2-3 days ago, which is the one you saw in the video. Yes, yes, yes. And there they are, disappearing. Boom. But recreating it took a fair bit of troubleshooting, as I'm still relatively new to the microbit. But this is awesome. And skull face. So that's all for the tutorial. I had a lot of fun. I had a lot of fun playing with this microbit program and had fun programming it. I'll be taking it to the classroom this Saturday, so that should be interesting. In the meantime, stay tuned, subscribe if you like this video. If you're here at 25 minutes, do like it. So much for now. Take care. Bye all.